We're on page 113, topic 20. Problems that we're going to do are 1P here, 1K, and 1T. So from problem 1, we're going to do P, K, and T. And from problem 2, we're going to do I, P, and problem U. So let's get started and start with 1K, which is 5 plus 15 squared equals 50. And here we remember that if x squared equals k, then x equals plus or minus the root of k. So we take the square root of something that's squared, as we do over here. We go from take the square root of both sides. We're left with 5x plus 15 from here. We take the square root of this, and going from here to here, we take the square root of 50, we get plus or minus 50. Now 50 is 25 times 2. 25 is a perfect square, so we can take it out. So we can rewrite this as 5 root 2. So we're just taking 50, saying that it's equal to 25 times 2 within the square root sign. Square root of 25 is 5. We take it outside the square root sign, and we're still left with the square root of 2 inside the sign. So the way to look at this going back is if I put this back in here, it becomes 5 squared. 5 squared times 2 gives me 50. All right, so what we're doing is applying this rule of x squared equals k. In this case, k is 50. And if I take the square root of the left side, I get 5x plus 15. If I take the square root of the right side, I get plus or minus root 50, which becomes this. Now I'm going to divide each term here through by 5 to simplify it. So 5x divided by 5 gives me x. 15 divided by 5 gives me 3. And plus or minus 5 root 2 divided by 5 gives me plus or minus root 2. So the solution is minus 3 plus or minus the square root of 2. If I go back, here's the solution, and I put this back into the left side, 5x plus 15 squared. I get 5 times minus 3 plus root 2, which is x. So I'm replacing the x by this. Plus 15 is this term right here, and then I'm squaring it. So now 5 times minus 3 is minus 15. 5 times plus root 2 gives me 5 root 2. So the minus 15 and the plus 15 cancel, and I get 5 root 2 squared. 5 root 2 squared, the root of 2 times the root of 2 is 2. And 5 times 5 is 25. So 25 times 2 gives me 50. And the right side is also 50. So the left side becomes 50. The right side is also 50. So the left side equals the right side. And if I do the same thing with the other solution, okay, which was minus, remember it was minus 3 plus or minus the root of 2. I'm going to choose the minus one here, and I replace the x by minus root 3 minus root 2. I get minus 15 and minus 5 root 2 plus 15 right over here. So the minus 15 plus 15 sum to 0 as they did in the last check. And now I have minus 5 root 2 instead of plus 5 root 2. But when I square that, I get the same answer of 50. So these are the two solutions. Now, this is an exact solution. If you want to go one step further, the square root of 2 is 1.414, 1.414. So you could add minus 3 plus 1.414, or do minus 3 minus 1.414. But this is an exact solution. square root of 2, 1.414, and that's just an approximation because this is an irrational number. Okay, here we have x minus 1/3 squared, number 1p, equals 5/9. If I take the square root of both sides here, this becomes this. Square root of this squared becomes this. And the square root of this becomes plus or minus the square root of 5/9 as the square root of 5/9. And instead of the square root of 9, I'm going to leave it as 3. So I'm going to take the root away from that. And I get plus or minus root 5/3. So because both of these are 3, we can write that x equals transpose the -1 from the left to the right. I get 1. This -1 here becomes +1. And I get plus or minus, because of this, root 5/3. So now I'm going to check both solutions. X minus 1/3 squared, if we go back to this equation here, left side of it, x minus 1/3 squared, and I'm going to replace the x with 1 plus root 5/3 minus 1/3. Now here the 1 and the -1 sum to 0, so I'm only going to be left with root 5/3. In other words, the 1 here and the -1 here sum to 0 inside the brackets. I'm just left with the root of 5/3 all squared. So root 5 times root 5 gives me 5, and 3 times 3 gives me 9. The right side is 5/9, and so the left side equals the right side. Now, here, I'm going to choose the other solution. I'm going to choose this solution over here, get x minus 1/3, and instead of x, I'm going to write 1 minus root 5/3, which is this solution. Here I did 1 plus root 5/3. So now again, the 1 and the -1 sum to 0, and I'm just left with root of 5/3 squared. So the minus times the minus, because I'm multiplying itself, becomes plus, and root 5 times root 5 becomes 5. 3 times 3 becomes 9, so we get the same answer. So again, here, the root of 5 is about 2.2. It's an irrational number. If you wanted to, you could give approximate answers as 1 plus 2.2/3 or 1 minus 2.2/3. But those would be approximate answers. These are exact answers here. 2 answers right over here. Okay, question number 1. X squared plus 14x plus 49 equals 31. The key thing is to realize that this is a perfect square, so we can therefore write x plus 7 squared. And if we take the square root of this side, we get this. And if we take the square root of that, we get that. So this really emulates the previous 2 problems that we've done on number 1. We create a perfect square here. We take the square root of it here. Square root of this is this. So we have 2 solutions. When the plus 7 is transposed from the left to the right, we get -7. So let's check the answer. -7 plus the root 31. We're going to put it back into the original equation, which is right here. So we have -7 plus root 31 squared plus 14x. So this is x right here, and this is a plus 49. So instead of x squared, we're going to write this. Instead of 14x, we're going to write this. And instead of 49, we're going to write this. So this squared, the first times the first, gives us 49. -7 times -7 gives us 49. And root 31 times root 31, the last times the last, gives us 31. And if you check the middle term and the inner term, it's -7 7 root 31, and the outer is also minus 7 root 31. When we sum them, we come out with minus 14 root 31. So here are the three terms from this. Now 14 times minus 7 is minus 98. 14 times root 31 plus root 31 gives us this, and this remaining term is this one here. So now if we sum the terms 49 and 49 over here and subtract the 98 from here, so I'm adding 49, 49, and minus a 98, and then I've got this term right here, 31. So there's four numbers, if you like, complete numbers without root sign. 49 plus 49 minus 98 plus 31. So 49 and 49 gives you 98. 98 minus 98 is 0. 31 gives you 31. And you have a minus 14 root 31 and a plus 14 root 31, which sum to 0. So the left side of the equation is 31. The right side right over here is 31. The left side equals the right side, so that's a valid solution. Now we do the same thing with the minus root 31 instead of plus root 31, which is the other solution, and substitute it in over here. We get minus 7 minus root 31, replacing the x here, which is squared, plus 14x. So minus 7 minus root 31, this right here, plus 49. So first times first gives me 49. The last times the last gives me 31. Now, the minus root 31 times minus 7 gives me plus 7 root 31, and both inner and outer are both positive, so I have 7 root 31 and 7 root 31, which gives me 14 root 31. So these are the three terms coming from this. Then 14 times minus 7 is minus 98, and 14 times minus root 31 is minus root 31, and this is 49. So again, I collect all the numbers, 49 plus 49 minus 98 plus 31. So again, these sum to 31, and I have a plus 14 root 31 here, and a minus 14 root 31 with sum to 0. So that gives me. Again, here, this is an approximate. The root of 31 is somewhere, I would guess, around 5.5, something like that. How do I know that? The square root of 25 is 5, and the square root of 36 is 6. So I know that 31 lies between 25 and 36, sort of halfway. So I know this is going to be approximately 5.5. So I could take minus 7 plus 5.5 would give me one of the solutions, and minus 7 minus 5.5 would give me the other solutions. So let's now go to problem 2i. Minus x squared plus 2x plus 12 equals 0. Again, there's no easy way to factor this, so we're going to use the quadratic equation. A is minus 1, is the coefficient of x squared. B is 2, right over here, and C is plus 12. And if we put that into the equation, we get minus 2 plus or minus b squared is 2 squared minus 4. A is minus 1, and C is 12. So what we get here is 4 plus 48, which will give us 52. And by the way, 2a is 2 times minus 1. So we get minus 2 plus or minus 52 over minus 2. Now, the square root of 52 is 4 times 13. 4 times 13, right here. When I take the square root of 4, I get 2, and then I'm just left with root 13. So now I can divide minus 2 into minus 2 right over here. Minus 2 divided by minus 2 gives me 1. And this 2 divided by this 2 cancel also, so I get root 13. So I get the two solutions, 1 plus root 13 and 1 minus root 13. Okay, so let's check the 1 plus root 13. We're going to put that back into this equation here. The left side is this. So we get minus 1 plus root 13 squared. Put the minus outside here, and we do this first inside the brackets. First times first gives me 1. The inner and outer sum to 2 root 13. And the last times the last gives me the 13. This is 2x right here, and this is plus 12. 2 times 1 is 2. 2 times root 13 is 2 root 13, and plus 12 is this. Now, when I apply this minus to each one of these, it becomes minus 1, minus 2 root 13, and minus 13. This is still plus 2. This is plus 2 root 13 plus 12. Now let's see how this works out. Here we have minus 1 minus 13 is minus 14. Plus 2 is minus 12. Plus 12 is 0. And the minus 2 root 13 and plus 2 root 13 sum to 0. So everything sums to 0. And the left side equals 0, and left side equals 0, and you can see the right side is 0. So this is an exact solution, and it works out. The other solution is 1 minus root 13. So I put this into this equation. Here's the left side of the equation. I get minus 1 minus root 13 squared plus 2x. Replace that by 1 minus root 13 plus 12. Here I work this out. First times first gives me this. Minus root 13 times the minus root 13 gives me plus 13. And the inner and outer, because it's a perfect square, sum to minus 2 root 13. When I apply the minus sign and the distributive rule, I get minus times a minus gives me a plus. This minus and this plus gives me a minus. And I get plus 2 is this is this, and this is this. Okay, let's sum it up. Minus 1 and minus 13 is minus 14. Plus 2 is minus 12. Minus 12 and plus 12 sum to 0. The plus 2 root 13 and the minus 2 root 13 sum to 0. And so the left side equals 0. The right side is also 0, so the left side equals the right side. Again, the root of 13, I don't know what that is. It's somewhere around, I would say, if the square root of 9 is 3 and the square root of 16 is 4, I would say probably this is somewhere around 3.8 or something. You can work it out on your calculator. So an approximate solution would be 1 plus approximately 3.8 if I've got it right, and 1 minus 3.8. So that will give you the approximate solutions too. Okay, so here we have x plus 3, x minus 2, and we're going to solve for x. So we're just going to use it, multiply the first times the first gives me x squared. The inner is minus 3x, and the outer is plus 2x, so that sums to minus x. And minus 3 times plus 2 is minus 6. Now I'm going to transpose the 2 from the right side to the left to make it minus 2, and here I have the formula. And there's no way to factor this. There's no way that you're going to be able to factor it. So In order to solve this, we're going to use the quadratic. B is 1, so we have minus 1. So 1 squared is 1, minus 4. A is 1. Let's look at C. C is minus 8. So minus 4 times minus 8 is plus 32. 1 plus 32 is 33. And of course, 2a, if a is 1, is just 2. So here's our two solutions. Minus 1 plus root 33 over 2, and minus 1 minus root 33 over 2. You're going to check the minus 1 plus root 33 over 2. You're going to put it back into the original equation. Okay, the left side. So here's the left side of the original equation. I'm replacing this x with this term right here. And this x over here is this x over here. Plus 3 is this, and the minus 2 is this over here. So I'm taking the left side here, and I'm replacing the x with this. So now what I'm going to do is get a common denominator. Instead of 3, I'm going to write 6 over 2. So I have the same denominator here. And instead of minus 2, I'm going to write 4 over 2, because 4 divided by 2 is 2. So now these two have the same common denominator. And you'll see minus 1 plus 6 gives me the plus 5. And minus 1 and minus 4 gives me minus 5 when I sum them. And I still have the plus root 33 over 2 and the plus root 33 over 2 here. Now, let's multiply the first times the first here. I get minus 25. The inner term is going to be, and by the way, 5 times minus 5, and I have to multiply the 2 by the 2, and that's why I have the common denominator. So 2 times 2 gives me the 4 right here. 5 times minus 5 gives me minus 25. Now, if I take the inner one, here I get minus 5 root 33. And if I take the outer one, I get plus 5 root 33. Isn't that nice? The 2 will cancel. And plus root 33 times plus root 33 gives me plus 33. So what I'm doing is using the FOIL. First times the first gives me this. The inner one is minus 5 root 33. The outer one is plus 5 root 33. And the last times the last gives me this. So, and of course, 2 times 2 gives me the 4 here. So you'll notice that the minus 5 root 33 and the plus 5 root 33 cancel. 33 minus 25 gives me 8. 8 over 4 is 2. The right side is 2, so the left side equals the right side. Same kind of thing when we choose the other solution, x minus 1 minus root 33 over 2. Here's the equation. I take the left side and I substitute this value for x. So instead of this x, I'm going to write minus 1 minus root 33 over 2. Plus 3 is this plus 3. Instead of this x, I write this, which is this term here. And this minus 2 is that. And then I try to combine these because it's hard for me to combine them unless they're with a, I can't combine them unless they have a common denominator. So instead of 3, I write 6 over 2. Instead of 2, I write 4 over 2. And so now you can see, take the common denominator, add these. 6 minus 1 gives me 5. And minus 1 and minus 4 gives me minus 5. Still got the root 33 right here and here, so I have them here and here. Okay, so when I multiply 5 times minus 5, what I get? Minus 25. The inner term is plus 5. Because this is a minus, and this is a minus, I get plus 5 root 33. I multiply minus root 33 times plus 5, I get minus 5 root 33 as the outer term. The last times the last gives me plus 33. So in the same way, this term and this term sum to 0, minus 25 plus 33, like in the last, give me 8. 8 over 4 is 2. Now, again, the square root of 33 is probably around 5.9 if you wanted to do an approximate solution. How do I know that? The square root of 25 is 5, the square root of 36 is 6, but 33 is much closer to 36 than it is 25. So this is probably around 5.8, 5.9. You can work it out with your calculator. So the last problem we're going to do here is 2u. And here we have x plus 1, x plus 2. Solve for x by the quadratic formula. So first thing we're going to do is multiply. We want to get rid of this denominator here. So we're going to multiply each term through by x plus 2, x plus 3. When we multiply through by x plus 2, x plus 3 on this term here, the x plus 2 cancels, and I'm going to be left with x plus 1 times x plus 3. If I multiply this term by x plus 2 and x plus 3, the x plus 3 cancel, and I'm going to have the original x plus 2 and this by this. So all I do is take this and multiply by this term, this term. If I multiply 1 by x plus 2, x plus 3, I get this. So all we're doing is multiply each term above by this, which is the denominator. And that way, why do we do that? Because now we no longer have a denominator. We don't have the denominator. So the object is to get rid of the denominator. Now, this becomes x squared plus x plus 3x becomes plus 4x, inner and outer combined. Plus 1 times plus 3 gives me plus 3. First times first gives me x squared, inner and outer sum to 4x. And the last times the last becomes plus 4. Now on the right side, I have first times first is x squared. The inner one is 2x, the outer is 3x, the sum to 5x. Plus 2 times plus 3 gives me plus 6. So you can see that if I do this, I have x squared with sums to 2x squared, and here I have x squared. I'm going to transpose that to the left, and 2x squared minus x squared gives me this x squared here. Let's do the same with the other terms. 4x plus 4x is 8x. I'm going to bring this over. 8x minus 5x, when I bring it over, 8x minus 5x is going to leave me with 3x. Here I have 3 plus 4. I sum them to 7. Sorry, 3 plus 4 is 7. Transpose the plus 6 to the left side again. Minus 6, 7 minus 6 is plus 1. So this whole thing, if I collect the terms, reduces to this. I can't factor this. So I'm going to use the quadratic, and I get, substituting in here, b is 3, so minus 3 plus or minus b squared is 3 squared minus 4, a is 1, c is 1. C is 1, coefficient of x squared is 1. So I have 9 minus 4, which gives me 5 under the square root of sine. So I have minus 3 plus or minus 5 over 2 as the exact solution. Now, in order to check this, this is a little more complicated. So you can see that I'm going to put the x equals minus root 3 plus 5 over 2 into this right here. I'm going to start with the left side. And I'm going to replace the x here with minus root 3 plus 5 over 2. Every x here is going to be replaced by minus 3 plus root 5 over 2. So I'm taking this, I'm replacing this x here, this x here, this x here, and this x here with this here. Now I put a red line in so that you understand there's an equal sign. It doesn't all run together. So instead of 1, I'm going to write 2 over 2, so we get a common denominator. Instead of 2, I'm going to write 4 over 2. Instead of 2, I'm going to write 4 over 2. And instead of 6, I'm going to write 6 over 2. Now, what happens is, if I take the common denominator 2, minus 3, and add the 2, I get minus 1. If I take the minus 3 and add the 4, I'm going to get plus 1. If I take 4 minus 3, I'm going to get plus 1. If I take 6 minus 3, I'm going to get 3. But I still have the common denominator here. But I'm allowed to cancel the denominator here with the denominator here and cancel this denominator here with this denominator here. So now that simplifies. I'm not canceling this with this. I'm canceling this because it's the same as this. I can what we call invert and multiply, but when I have the same denominator, I can just use the numerator here and the numerator here and come out with this. So I'm canceling the 2 here. I'm canceling this 2 with that 2. And I'm left with root 5 minus 1, root 5 plus 1. Here I'm left with root 5 plus 1, and here I'm left with root 5 plus 3. Now, I've got my common denominator here, root 5 plus 1, root 5 plus 3. And because the common denominator is this, root 5 plus 1 goes into this, root 5 plus 3. So I'm going to multiply this by root 5 plus 3. Similarly over here, if I divide this into this, I'm left with root 5 plus 1. So I'm going to multiply this by root 5 plus 1. Now, so what I get here is root 5 times root 5 is 5. I've got minus root 5 plus 3 root 5, which sums to 2 root 5. And minus 1 plus 3 gives me minus 3. First times the first here gives me 5. I've got plus root 5 plus root 5 gives me 2 root 5. And 1 times 1 gives me 1. So you can see over here that what I've got is 5 minus 3 is what? 2. 2 plus 5 is 7, plus 1 is 8. So I'm left with 8. And here I've got plus 2 root 5 and plus root 2 root 5, but I got 4 root 5. Now, when I do the denominator here, root 5 times root 5 gives me 5. The inner and outer terms, this is 1 root 5 and 3 root 5 sums to 4 root 5. And the last times the last gives me plus 3. So 5 plus 3 equals 8 plus 4 root 5. So this sums to this, and this sums to that. So this gave me these 3 terms. This gave me these 3 terms. When I combined all 6 terms here, I got 8 root 5. When I combined these 3 terms, I got 8 plus 4 root 5. These are the same, so it's 1. Now, the solution for the other one is exactly the same and go through the same kind of procedure. I'm not going to do it. It's something you can see and you can practice on your own. But I think if you understand the first one, you will understand the next one. This is a more difficult problem, obviously, and it's a kind of problem that would really force you to see whether you how well you're doing in algebra. I think it's a real sort of a backbreaker kind of a problem, but a very interesting one. So this completes our discussion of page